Click the bell icon to get latest videos from Ekeeda.
Hello friends, so let's start with the next problem which is based on de Moivre's theorem. So here I'm gonna solve 4 different sub questions with the help of de Moivre's theorem. So here cos alpha plus cos beta plus cos gamma is given as 0, and the value of sin alpha plus sin beta plus sin gamma is given as 0. And guys, we have to prove that sin square alpha plus sin square beta plus sin square gamma equal to cos square alpha plus cos square beta plus cos square gamma equal to 3/2, and we have 3 more results. Now the question is how to get the solution. Now, when such type of question comes, many students think about the trigonometry. So they think that we can solve this problem with the help of trigonometry. But guys, let me tell you that we are in complex number, so we have to take help of complex number to solve these problems. Now guys, since you can see that question and answer both has terms like sine and cos, I will consider few complex number in polar form. So here you can see that we have angle as alpha, beta and gamma. So I can assume 3 complex numbers. Let's say one will be cos alpha plus I sin alpha, second will be cos beta plus I sin beta, and cos gamma plus I sin gamma. So guys, here I've assumed 3 complex numbers as A, B and C. Now let's go back to the question and observe the required answer. So here in the solution we have to derive these 4 results. So to get these 4 results, what I'm gonna do is I'm gonna derive few relationships between A, B and C which are our assumed complex number, because then only it will be easier to solve this question. Because guys, you can see here that every time if you see the angle, it is different. In the second result we want angle as 2 alpha, 2 beta and 2 gamma. In the third result we want angle as alpha plus beta, beta plus gamma, gamma plus alpha. And in the first result the angle is same as the question, but the thing is here the trigonometric function has square. So what we have to do is we have to derive some relationship between A, B and C which are the assumed complex number, and then it will be easier to bring this answer with the help of de Moivre's theorem. So now guys, what I'll do is here I will add these 3 complex numbers. So we'll find out the value of A plus B plus C. So we all know that whenever we add any complex number, we add real part with the real part and the imaginary part with the imaginary part. So here I'll add cos alpha with cos beta plus cos gamma and sin alpha with the sin terms. So we'll get now guys, let's move ahead. So by looking at these 2 values, you can easily say that these 2 values are 0 because it is given in the question. So in the question we have cos alpha plus cos beta plus cos gamma 0, as well as sin alpha plus sin beta plus sin gamma 0. Therefore I can say that the answer is 0. So therefore the value of A plus B plus C is 0. So here I got one result. So I'll say this as equation number 1. Now guys, we'll take reciprocal of these 3 complex numbers. So let's say if I want to find out 1 upon A. So here I'll find it out. So 1 upon A, we all know it is cos of alpha minus I sin alpha. Next, the reciprocal of B is 1 upon B, which is cos of beta minus I sin beta. And similarly, value of 1 upon C is cos of gamma minus I sin gamma. Now guys, what we'll do is we'll add these 3 reciprocals. So we'll get 1 upon A plus 1 upon B plus 1 upon C. So when we'll add these 3 complex number, that will be addition of real part with real part. So cos alpha plus cos beta plus cos gamma, that will give us 0. And then we'll add imaginary part with the imaginary part. So minus I common, and sin alpha plus sin beta plus sin gamma will also give us the 0 because these 2 results are given in the question. So that is why the answer is equal to 0. Now we'll simplify this left hand side by taking the LCM. So here we'll get B into C plus A into C plus A into B whole upon ABC equal to 0. And then we'll shift this ABC to the RHS. ABC into 0 will become 0. So therefore we'll get AB plus B into C plus C into A equal to 0, and this is our result number 2. So guys, here we got the second result. So now with these two results, we'll solve the further question to get the solution. So now guys, to get the first result, that is the sine square alpha plus sine square beta plus sine square gamma, what we must do? So we should take the square of the trigonometric function, and to take the square of the trigonometric function, we have to take the square of the complex number. So it means we have to take square of this cos alpha plus I sin alpha. Similarly for this cos alpha plus I sin beta and cos gamma plus I sin gamma. It means guys, I have to take square of A, B and C. So what we'll do here is, we will take one algebraic formula, and in that algebraic formula we'll substitute the value. So I'll take the algebraic formula in terms of A, B and C. Here I'll say the value of A plus B plus C the whole square is given as A square plus B square plus C square plus 2 times AB plus BC plus CA. So guys, we have seen this result in 11th and 12th standard. So I've taken square here purposely because in the answer or in the given question, we have to prove that the value is sine square alpha plus sine square beta plus sine square gamma. So it means we want square over there. Now guys, let's put the values. So for A plus B plus C, we have the value in the equation number 1, and that is 0. So left hand side will be 0. Next, A square plus B square plus C square will remain as it is. And here AB plus BC plus CA, guys, you can see here from equation 2 it is 0. So it means this value is also 0. So it means we got A square plus B square plus C square as 0. And now in this equation, I am going to substitute the value of A, B and C to get the result. So value of A is cos alpha plus I sin alpha. So we'll get So guys, here we have taken square of these three complex numbers, and now we'll apply the de Moivre's theorem. So by de Moivre's theorem, this 2 will come inside, and that will become cos 2 alpha plus I sin 2 alpha, and similarly in the remaining two terms. So now guys, here we got this step, and in this we'll add the real part with the real part and the imaginary part with the imaginary part. So we'll get cos 2 alpha plus cos 2 beta plus cos 2 gamma as a real part, and then taking I common, we'll get sin 2 alpha plus sin 2 beta plus sin 2 gamma as the imaginary part. And now guys, we'll compare two sides. So on the left hand side we have a complex number, on the right hand side we have 0, which is nothing but 0 plus 0i. We can assume this as a complex number, and since the equal to sign is given in between, by comparison we can equate the real part with the real part and the imaginary part with the imaginary part. So by equating, we'll get cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to 0, where both are the real part, and sin 2 alpha plus sin 2 beta plus sin 2 gamma is also 0. Now guys, if you observe this first result, then that was our question. So here in the question, you can see that we have derived this result. Now from this result, I will derive the result number 1. So for that, what I'll do is, I will substitute the trigonometric formula for cos of 2 alpha, cos of 2 beta and cos of 2 gamma. So guys, the formula for cos of 2 alpha is 2 cos square alpha minus 1. Similarly, I'll substitute the formula for these two terms. Now guys, minus 1 minus 1 minus 1 will become minus 3. That will go to the right hand side and will become plus 3. and then on the left hand side we'll get 2 cos square alpha plus 2 cos square beta plus 2 cos square gamma. Out of that we'll take 2 common and we'll send that 2 also on the right hand side. So on the right hand side we got positive 3, and then that 2 will go and divide here, that will become upon 2, and on the left hand side we'll just get cos square alpha plus cos square beta plus cos square gamma. And guys, you can see that this is our question number 1. So we've derived the first result as well. Now in the first result we have to prove one more side. So here you can see that we have to prove that sin square alpha plus sin square beta plus sin square gamma, that 2 is equal to 3 by 2. So let's start. So for that, guys, what I'll do is I'll substitute the formula for cos square alpha in terms of sin square alpha. So we all know the value of cos square alpha is 1 minus sin square alpha plus the value for cos square beta is so guys, here I have substituted 3 values. Now these 3 negative terms will shift to the right hand side. Those 3 will become positive, and this 1 plus 1 plus 1 is 3, so that will become 3, and this 3 by 2 will come to the left hand side, will become minus 3 upon 2. So that will be sin square alpha plus sin square beta plus sin square gamma. And now guys, we know 3 minus 3 by 2 is 3 by 2. So we'll get sin square alpha plus sin square beta plus sin square gamma as 3 by 2, which is the required answer. So it means we have proved these first 2 results. Now let's move to the third and fourth result. Now guys, here you can see that in the third and fourth result, the angle is addition of 2 symbols, that is alpha and beta, where alpha and beta are also the angles in the question. So it means we want 2 angles which are adding each other, and that is possible if and only if we multiply 2 complex numbers in polar form. So guys, for this we have a result which is derived in equation number 2. So you can see here that AB plus BC plus CA equal to 0. It means I am multiplying 2 complex numbers. So we'll use this equation to derive the result number 3 and 4. So let's substitute the value of A, B and C over here. So guys, here I am multiplying these 2 brackets. So this is the value of A and this is the value of B. So I got AB plus BC. So now I'll substitute the value of B and C here. So plus CA. So equal to 0. So I substituted the complex number in the equation number 2. Now we'll multiply this. So whenever we multiply 2 complex numbers in polar form, that time we add their amplitude. So here we will get cos of alpha plus beta plus I sin alpha plus beta. So guys, if you don't know this identity or this result, then you have to go back to the basic videos of complex number, where I have covered how do we get this result by multiplying 2 complex numbers in polar form. So similar result we'll get here for the second term and the third term. So we'll get, now guys, here in this result we got real terms and the imaginary terms. So we'll add the real terms with real terms and the imaginary terms with the imaginary terms. So these 3 are the real terms. So I'll add it. So we'll get and from the imaginary terms we'll take I outside, and in the bracket we'll get these 3 sine terms. Now guys, again what we did in the previous problem, we'll compare left hand side with the right hand side, and by comparison we'll get this real part equal to 0 and the imaginary part equal to 0. And guys, that is the result number 3 and 4. So if you see here, we have proved this result number 3 and the result number 4. So guys, I am sure you understood the 4 results, how I have derived it. So don't forget to share this video with your friends, and don't forget to subscribe to Ekeeda channel, because then only you will be able to get the latest updates about the videos that we are posting every day. Thank you very much.